Okay, so one more time. I just realized that I missed recording the last few minutes. I'm so sorry, but I have to say this again just for the camera, for you to review this. Sorry about that. So I stopped and I forgot to turn it back on. We are given a piecewise defined function. We realize that these two pieces are polynomials, they are continuous, but we are not sure whether the function is continuous at 1. If the limit from the left of x squared plus 1 equals the limit from the right of x plus 1 and equals the function value, and it happened that all three were equal, then we said the function is continuous. But what we don't know at 1, it's continuous everywhere, but we don't know if there is a corner at 1. If there is a corner or a cusp or vertical tangent, then the function will not be differentiable at 1. So for now, I will differentiate both branches, and I see that this is 2x and this I see that this is 1. But when x approaches 1, 2x means slope of 2. When x approaches 1, this means slope of 1. So because of that, what am I showing there? I'm showing this. Here the slope is 2, and here the slope is 1 at that corner. So we picked values to the left for x squared plus 1 and to the right for x plus 1, and also here for 2x. So at -1, at 0, at 1, on this side is always 1. So then we graphed these points, -1, 2, 0, 1, 1, 2, and 2, 3. And we graphed continuous, but it has a corner. Why? How do I know? Because the slope of the tangent from the left is 2, the slope from the tangent from the right is 1, which means right here. This is 2, and this is 1. Therefore, the derivative has a jump. It's not defined there at all. So that's why I cannot go back and put the equal symbol here. And I will say continuous at x equals 1, but not differentiable at x equals 1. Corner. Okay, and remember we graphed these one below the other, so I can show that at this point this happens, at this point this happens, at this point this happens, and so on and so forth. That's why this x has to be under this x, and so on and so forth. Okay. Any questions for me? Any questions? Okay, so we are moving on now to section 3.2. We are going to add more rules, and we're going to add rules for a while. So 3.2, product and quotient rules. I accept other options. I recommend the following, but if you are used to a different setup, I agree with it. So I like to write this. When we have a product of two functions and we want to differentiate, I like to write f prime times g plus f g prime. Your book may twist this or may twist this, whatever you prefer, it's fine. Why I like this is because it's the first function times the second function prime, the first prime times the second not prime, of course, plus 1 times the second prime. It's a matter of habit. You will develop your own, and I'll accept it. I like this one because I like to keep everything in this order. 1, 2, 1, 2, 1, 2. I don't want 1, 2 equals 1 prime 2 plus 2 prime times 1. I don't like that. But I accept it. It's correct. I like 1, 2, 1, 2, 1, 2. Now, the quotient rule f divided by g. When we differentiate a quotient, we're going to have the same thing at the top, but with minus, and the denominator is not differentiated, it's just squared. So it's the same thing, but minus. So f prime g minus f g prime. Or if you want to write it as 1, 2, 1, 2, I prefer this. You do whatever you want, over 2 squared. However, be very careful, because if you twist these without paying attention to the sign, that will be incorrect. Okay, for now we want to practice these rules. I'm going to share my screen, and we go to section 3.2. Before I forget, there is something called derivatives assessment, the last one. We had the skills assessment. We have one more, the derivatives assessment. This will be due pretty soon. I'll show you where it is, and we'll talk about it. We are not there yet. We have a lot of rules to go through before we go there. Oh, I'm sorry, you couldn't see what I was just saying. So derivatives assessment is the second and the last one for the semester. It has to be turned in only in Canvas, not in WebAssign, only in Canvas. Okay, so here it is, from 3 to 30. We want to practice the product rule. We want to practice the quotient rule. So let's choose. You can say for number 4, I will just distribute. Who cares about the product rule right now? Well, we want to practice it. Yes, in this particular case, I would not use the product rule. I will distribute and then differentiate. But we are getting ready for differentiating something like this. So let's say I have x squared plus 10 to the 10th power and e to the x plus 2x to the 3rd to the 4th power. I will get old before I get to the answer. I again say I'm old already. So I agree with you. But I will never raise this to the 10th power and raise this to the 4th power and then distribute. It will take me an hour to do that. So this is what we are getting ready for, but we're not there yet. Okay? So that's why we need to practice the product rule and we need to practice the quotient rule. So we are not going to distribute. The answer will be the same for number 4 if we distribute or we don't initially. But we want to practice the product rule. So anyone would like to choose? Oh, okay, I will choose 7. If you don't want to choose, I will. And f of x equals 3x squared minus 5x and multiplied by e to the x. We are not going to distribute, although you could. In this case, even if we distribute, we will still have to use the product rule. We have no choice anyway. That's why I picked that. So this is my function 1, and this is my function 2, and this is the product. So when I differentiate, can anyone give us the derivative of this? And then I'll multiply by e to the x. Can anyone differentiate this? And I'll put it here.
6x minus 5.
Very good. Plus, now I have to copy it. Can anyone differentiate e to the x? And I'll put it here.
Yeah.
E to the x. Can I simplify? Yes, a little bit. and I will factor out e to the x. So then I have 6x minus 5 plus 3x squared minus 5x. I will write e to the x and then arrange this correctly. Plus x minus 5. And this is it. Perfect. Okay. So let's practice now the quotient rule. We'll come back to the product, whatever you want. So again, let's notice what I did. This prime times this plus this times this prime. And then the rest was algebra. One more time. 1 prime times 2 plus 1 times 2 prime. Okay, we need another product, or we look at the quotient. Any preference?
Another product.
Okay, very good. Awesome. Anyone would like to choose?
Number 6.
Perfect. Number 6, we have y equals e to the x plus 2 and 2e to the x minus 1. Perfect. So remember the product rule. So this is number 1 and this is number 2. If you're using what I suggest, so dy over dx, we have to get used to this notation anyway. Or if you want to denote this by f of x, that's fine. So I recommend 1 prime times 2 plus 1 times 2 prime. So can anyone give us the derivative of this? Can anyone differentiate this function so I can put it here? E to the x, perfect. Plus, now I copy the first function. Can anyone give us a derivative of the second function? And I'll write it here. Anyone? Please, anyone? The derivative of 2e to the x minus 1.
2e to the x.
2e to the x. Yes, I will factor out e to the x, this one. And then I have 2e to the x minus 1. But now I have to distribute 2 in here, plus 2e to the x plus 4. So then I continue, e to the x, 4e to the x plus 3. And that's the final form. E to the x, 4e to the x plus 3. Good. Let's practice the quotient rule now. Anyone would like to choose? This is not the quotient rule. This is the product rule. This is the product
Can you
rule.
scroll back up a little?
Yes, yes.
A little more. I think there was like a linear over quadratic.
In the 13? 13 is a
I'm not
linear.
sure what I saw originally. That's fine. I thought I saw something different.
Okay, so that is a linear over quadratic. Actually, it's not quadratic, it's cubic, but three
No, that
terms.
one. I thought I saw a quadratic one, but I could have misseen it.
Maybe this one.
It doesn't matter.
Okay, so
Maybe 13.
13. Okay, very good. In 13, we have f of t equals 5t. Everything divided by t to the third minus t minus 1. Perfect pick? Good. Now, I want to draw your attention always to something that you can do to simplify. Now, remember a while back, I'm talking about tonight, we had this comment, algebraic trick. Okay. So this was a more complicated situation. We couldn't even differentiate because at that time we did not know the quotient rule. So obviously when I look at the function, I don't just start working on it. Just look at the function first. Relax, just look at it. Just observe and say, oh, okay, I see only one term. What if I do this? And I get a very simple simplification. Okay, the same thing here. There is nothing I can do to the denominator. It's a mess. 3 terms the denominator, there is nothing I can do. I can't touch that. But look at the numerator. The numerator is 5 times t. I will think in terms of doing this, because it's a factor. So 5t over a is the same with 5 over a times t. It's the same with 5 times t over a. So I want my students to realize that algebra is really helpful. And you can say, well, it's not a big deal. It's just 5. It's not 3,599,000, blah, blah, blah. True. But why worry about a constant if this entire function is nothing else but 5 times t over the denominator? Because when I differentiate, I have 5 times t over t cubed minus t minus 1 prime. Let me box this in. And then I have 5 times. And I don't have to worry about it. It can stay and wait patiently. Now if I have this, I can't do that, because the numerator does not have a factor anymore. But now the numerator has a factor. But with 3 in there, or 5, or maybe with 5, maybe I would have factored 5 anyway. But it's 5 times t, which can be written like this. Again, it's not a big deal. If you don't want to do that, you'll get the same answer. So now, when I differentiate the top and I get 1 times the denominator minus the numerator times the denominator prime over the denominator squared. Can anyone differentiate this so I can put it here? So one more time. The numerator prime is 1, so times the denominator, minus the numerator times the denominator prime. I need us to differentiate this and put it here.
2t.
So it's
for me to see.
3t squared minus 1. Is that clear?